attack could not get back on their networks. So not only were communications shut down, many other valid and valuable characteristics of things they were trying to get out to the field and to understand, they were unable to do that. So that secondary attack was what we would call a covert cyber attack, cyber war. It was targeting a US space asset, and how they started it in the prior February. Restraint of attribution. Now, the United Nations people have run up to me after some of this training and said, but you know, the United Nations has sanctions, has actual rules about post-mission disposal. And I said, well, that's all great. They have rules about it, but they have no sanctions in place. So we are left in this space many times where these occurrences happen without any type of retribution on our part. So thus why I'd like to introduce Bryan to come to the stage, because he's really here to talk to you about proactive, not reactive response mechanisms in what I call a business reasonable risk management scenario. So I'll hand it over to you.
Thanks for that, Shawana. Good morning. Yes, wicked problems. That's what we're trying to solve. So if we talk about worlds colliding, I think everybody is familiar with the term of cyber-physical. Sometimes I call that the family feud, the IT and the OT pieces. They don't talk to each other. When the cyber people come up to help somebody in a manufacturing plant, critical infrastructure, first thing they say is, hi, we're here from corporate, we want to help. And they want to start port scanning the floor. And of course, you can't do that. Two different worlds. I think we've evolved a lot since this term started coming out. And in reality, what we're trying to look at is not just the cyber-physical domain, which is complicated enough with all of the human aspects to it, and the harm that can be affected on human beneficiaries around safety, security, and privacy. But imagine all the other domains. So the themes, domains, and dimensions for this conference, very resonant with me. So if we acknowledge that these are problems and that they most likely will continue and that human beneficiaries will be harmed, then it behooves us to really understand what's going on and maybe change the dynamic. What we see a lot of these environments, it's the one that you didn't see to get you. So those hidden interconnections, those hidden dependencies, unmanaged assets, stuff that's off the books. I often say the secret to being invisible is to be somebody else's problem, right? So if you're not an asset that's tracked and treated like an asset, it's just that box in the corner. We don't touch that because the last time we touched it, the network went down. That's the one I worry about. And we also have these trends that are happening, very disruptive transformational trends in compute. I will try to resist using the AI term, and hopefully be the only one. But it's, they are disruptive and they are transforming, and people are actually running to use them. We also have a lot of things going on in the human domain, social domain, with social media, or what I call anti-social media. And then there is the lack of imagination for novel and emerging threats. Me being a child of the Cold War, sometimes I reminisce about that, because single adversary, unlimited budget. Certainly not the case now. And when we look at some of these scenarios, these don't necessarily have to be nefarious actions. They can simply be black swan events that because of the lack of imagination, we didn't plan for them. Now, I'm going to posit that I think with the way, with this approach and others that we're seeing, that we could have no black swan events in the future. Now, that doesn't mean we'll prepare for all of them, but we should acknowledge that they could happen and maybe have a break in case of emergency. But yeah, wicked things this would come. So I love modeling and putting things in little categories and then trying to understand the world that way. It's always kind of been my approach. I think it's a little bit small, but we're all familiar with the 7-layer OSI model that explains networking on the cyber side. We've added these 3 other for the 10, which are really individuals, organizations, and governments. And so you can't really just look in at this in one single domain. It's got to be holistic. And so when we look at trying to understand the world and putting these together, threat catalogs are really the thing that you can talk to other humans about, the stories that you can talk to them about to get them interested. I had a really great mentor leader when I was at Reed Elsevier, and I used to come in with some very creative use cases that we should go protect ourselves against. And he said, Bryan, that's all well and good, but you can't look at the 10,000 possibilities. We can only focus on the 20 or 30 that really matter. Well, now I think you can look at the world of possibilities because you have things like minor attack that takes those 10,000 bad things that could happen and distills them down to, the 3 or 4 tactics, techniques, and procedures, or the TTPs, that you need to be concerned with. And then you can look at the 4 or 5 controls that actually will prevent that from happening. And we're also entering a time in computer security where we used to be kind of, magic. Nobody really knows what we're doing. Well, we're becoming more and more of a science, and you'll hear terms like quantified security, quantified risk management. It really is becoming more of a science, and it should. So I think as an industry, we're growing up, which is a good thing. We're maturing. So organizations should have threat catalogs that are relevant to them, and they should also have the stakeholders involved in those processes. So some of the threat catalog items that I'm interested in general, extortion. Now you'll know these as ransomware attacks as a form of extortion. And I remember the first call that I ever received from somebody. It was a panic on a weekend, and they said, we have a ransomware attack, they're going to do something, it's going to happen Monday. And that whole exercise, the first question was, okay, what is your policy on extortion? Crickets, they didn't have a policy on extortion. And the adversary, the extortionists were asking for Bitcoin. And I said, well, let's assume that you want to pay, which I didn't advise them to, but let's just go down all possible routes. You're going to pay. And I said, do you have Bitcoins? And they said, what's a Bitcoin? Now, again, this is not the case today. Everybody probably knows what Bitcoins are. Everybody knows about the ransomware attacks. But back then, if you would have gone in and asked the people responsible for protecting that organization, how you slated for extortion, what's your policy on it? What's your playbook on it? They didn't have it. So if they would have had those, they could have saved a lot of time, a lot of stress, and probably reacted better. And so afterwards, that event, we went back, and guess what? They have a policy on extortion. They have playbooks now. So if you can do this before, or you can use somebody else's bad experience to go, advance your proactive protections, that can't be anything but good. Something we haven't seen that I expect to see more, especially we saw a lot of sabotage. We see here a lot of glitches. Is that death by 1,000 cuts, or is it just human fat fingering? I don't know. Quality control in manufacturing. A lot of people think it's the Coca-Cola secret recipe that's the asset. Actually, it's not. It's the manufacturing process to be able to produce that same product at a known price with a level of quality. Those manufacturing processes actually exist on the plant floor in the devices themselves. So you can imagine if somebody were to maybe nationalize assets because of a pandemic, I don't know, or many things that could happen, they seize that equipment, now they actually have this secret sauce. And we did see a lot of interesting counterfeit things happen during the pandemic. So, and then of course, these are a little bit more futuristic, but we're seeing them market or consumer or voter manipulation through either lying to robots or lying to people or abusing these systems. So, this goes way back, and I have a conference in Dayton, Ohio, and we introduced this maybe almost 20 years ago, but I call it POO, Point of Origin Hacking. And the idea is, and this is how I kind of explained it to my manager, this is why we really need to think about the theoretical. Because at some point, somewhere, some fun, interesting person looks at a system and says, if I were going to do something bad to this system, I would probably do that. And then they don't think about it ever again. But simultaneously, other people are doing that. And eventually, that point of origin, the spark of innovation, says, let's go build a capability. And let's maybe not give that to the world, not share the research, just keep that as a private capability. And eventually everybody else finds out about it. And then we can reach operational transparency when we sort it out. I'm not a bug hunter. I love architecture flaws because they can't be easily patched. And Shawana was mentioning being able to patch systems and things. Architecture is forever. So we are at a unique time with all these transformations going on. If we get this right, we can actually future-proof ourselves. And I know that's kind of a marketing term. But we can certainly change the maths that we currently have. So if you assume that a motivated adversary will eventually develop a capability, right, then it's reasonable to say stakeholders should consider all of these kind of esoteric, interesting, weird things. And if we can give them tools to easily identify and understand why it's important to them, then I think we can prevail. So let's talk about motivated adversaries. Now this is a series of work called Future Fraud, and I can share the slides with you, but basically in 2018, I was publishing another SANS GSEC gold paper, and it's a great process. Any SANS people in here? Well, anyways, it's an opportunity to write a paper and get published, but also have peer review to tell you that if you're getting it right or not. And so I did some of the lookups. About 2018, they had this concept of, they call it CEO fraud. You'll know it now as business email compromise. But it's like if we can go get the main honchos to go click on a link that then exposes a SWIFT transfer or does direct somebody to do something on their behalf, a corporate identity fraud basically, you can lose money. And back in 2018, we're looking at something like 1.1 billion pounds. So, and they never caught these people, so crime does pay. That's why they keep doing it. But when you look at it, the anatomy of that type of fraud is very simplistic. It's super easy to model. And then if you look at the stats, that proves out that crime does pay. Again, I know it's an eye chart, but every year, the numbers keep going up. And these are only the numbers that are coming from IC3. The FBI actually takes this information in that is voluntarily reported. There's a lot of stuff that's off the books. Now, if you're a publicly traded company, you have an obligation to disclose these types of things because they are material. But that's a whole other presentation. So the idea of saying, okay, crime pays, they're going to continue doing it, they're going to probably branch out in these other esoteric places, which deep fakes. So imagine a fuzzy phone call. Now we know not to pick up, right? But what if it's the elder fraud that we're seeing where we virtual kidnapping? Has everybody heard about the virtual kidnapping? Somebody gets a call, spoof caller ID, your grandson is being held, you must, in fact, in Ohio, somebody just got shot because it was the pickup person. And it was all remote control. No, they didn't get their hands dirty at all. They hired an Uber driver to go pick up the ransom, and the guy thought that she was part of the criminal organization and shot her. I mean, so there's, everybody loses, society loses, it's terrible. So just remember this. Serious adversaries, okay, they'll innovate. And nation states innovate, they do stuff. And it used to be 10 years before you figured out. That's not the same anymore. That timeline is even smaller. And others then imitate, and then you get the crime industries that automate. And that is the path, and it is getting shorter exponentially. And they can do it at scale. All right, so what is our reasonable response for this? In my opinion, professional opinion, model assessment simulation. Have a multi-domain view. So many of our simulations, we do it really well. Stovepipe. I love the concept of digital twin. For a long time, that was only available to, critical infrastructure governments. It's now available to everybody in every industry, practically. I think we're going to see lots of people talking about that this week. Automate and integrate, okay? Humans don't scale. And in fact, a lot of people are graying out, and a lot of that tribal knowledge, as it were, is not coming forward. There's no apprenticeships. Some of these jobs people don't even want. So that's a problem. Be careful when you automate. You must do process improvement before automation, because one way to fail at scale is automate a broken business process. So this is super, and for efficiencies too. So, and that's kind of a lost art also, as effective change control. Focus on what matters, especially when you're talking to stakeholders. Early on, when I was the person that said no and could never get anybody's attention, even though I was right, it was because I wasn't speaking in their language. I wasn't talking to them about what they care about. I often think we should all have little, name tags on, but also this is how I'm compensated. This was what motivates me. It would make communicating with each other so much simpler. That level of transparency. Governance. All right. I know this is going to sound geeky. I love governance, because to me, governance is really stakeholders getting together, agreeing to a way forward, and then going off and doing it. And a large organization without proper governance, you may be going in different directions, or worse, head-on collisions with each other. So get aligned on what matters. Have the holistic risk register. Many times when I come into organizations to help them, I say, hey, where's the risk register? Some cheeky guy will look, which one? Okay, then we have a problem. And that's a maturity problem around governance, because ultimately the mission, everybody should be going in the same direction. Getting these communities, that family feud I was talking about, the IT-OT digital divide, some of the best way, I was in CERN, and a professor, his name escapes me, but he said, you need bigger barbecues. And he said, I can't do Swiss accents, because you need bigger barbecues. I go, bigger barbecues? What are you talking about? He goes, barbecues. You're from the US. You guys go barbecue picnics. Yeah, breaking bread, creating forums where those diverse stakeholders can come together. And maybe not hash it out in a governance form, but just get to know each other, understand that ultimately you have good people in the organization, and you can learn from people. So remember I told you the story when the cyber person comes into the plant, and they want to do all the things that work well in the back office of the enterprise, but not in critical infrastructure. We can also learn things about good practices from the OT. Imagine these environments, which are arguably more of an engineering and science, precision and cyber. They just say, hey, this device only needs to talk to 3 devices. So I have an access list that can talk to 3 devices. And as long as I'm comfortable with that, whereas in an enterprise, if you try to put access lists in place, you break the internet. That's why we have so many issues. So just philosophically, make sure that you're open-minded and realize that everybody in your organization is professional and is motivated to do well. And they probably have something they can teach you if you're willing to listen. The operational insight, this is the human factor that I've learned. Remove discretion whenever possible. Say discretion should only be something allocated to a human or potentially a construct that looks or acts like a human. But make it easy to do the right thing and hard to do the wrong thing. If you do that from a design principle, you'll always be ahead of the game. All right, tools of the trade. So we looked at point of origin hacking. That's looking for the theoretical. When it becomes practical, let's make sure that we're prepared. Well, now we've proved it out. What are we going to do? How are we going to go about this? And so early on, and this is kind of the methodology that I'll take with walking you through these 3 use cases that we have. We're going to put it all together, which is basically articulating that there is a threat actor out there who would like to do something bad to you, which could equate you or your organization, which could equate to a threat catalog item. We built off of this one, which was one of the first in this series of cyber physical plane, trains, and automobiles, the Internet of Dangerous Things. That's the PG-13. There is an R-rated version, which is the Internet of Deadly Things. But we've all seen these kind of scenarios, and this was a first attempt to actually use these primitives that we've designed. And there's the technical papers here, you can look at it. And then take the idea of simulating the cyber operations. So about in 2014, people acknowledged that there was a shortage of cyber operation personnel. And so there was a whole bunch of programs that were being put together to retool, educate, and build up the human assets here. And so you'll see things like capture the flag games, simulations, immersive simulations. I actually run a sport called Packet Wars. I don't know if anybody's heard of that, but it's an immersive environment where you can put human teams, and they can be pure red teams, red, blue, or purple, and they'll run through some of these simulations and some of these scenarios that might be so esoteric. And one that we did in this era was something called Gridlocked. And that was, it's about 10 years ago, where we, essentially the premise was an EV charging system gets compromised, malware is introduced to electric vehicles, and then it morphs and creates a worm between, and communicates between the vehicle-to-vehicle communication system. So some of these standards aren't even out yet, but that is a very real scenario because we are seeing elements of it played out. But putting it in a simulation, modeling it, and then having some very interesting characters go and try to break the system or actually get into the adversary's command and control so they can take over the vehicles. Now, of course, the scenario that, the bad thing about this scenario is you only have to hit, what, 10% of the vehicles? If you stopped every vehicle in a certain country on the highway, just stopped it, what would happen to society? It's a pretty scary scenario, right? And that's just one attack. Now, if you have multi-domain attacks simultaneously, it gets scary. So I ask that everybody, if they get a chance, if this is interesting, go look at the prior art. You'll see how I can work with the modeling, and then you'll understand what some of these use cases are about. So this is an actual use case. I worked with a researcher, Gabe Weaver, who was doing some DHS work about 2016, 2017 on cyber physical systems. And it was really about multi-modal disruption. So the idea of what happens if we have a kinetic event and a cyber event at the same time that's actually engineered to affect a cascading failure. And what we did was, what he did, and then what we did, we basically took his real-world research and applied it to a scenario and did some simulations. But essentially, if this port's Everglades, almost all ports look something like this. So if this thing gets blocked, or a canal gets blocked, I mean, we haven't had any of those canal things happening that week, or simultaneously a train derailment, what could happen? And so I like to call this one, this is probably a dated reference, but the orange juice Mortimer. Basically, if you want to control the spot price or something like orange juice, there's a couple places that you could hit, and some of the kind of cargo that could be most impacted would be the bits that are time sensitive. So it's my understanding, especially in Florida, seafood. Right? If you can't get the seafood where it needs to be, or if you lose your air conditioning or freezing capability, you're going to lose a lot of product, and that's actually going to have a detrimental effect, certainly on the bottom line, but there's collateral damage, as it were. And so this scenario is basically, if you want to cause a manipulation of certain spot traders, you can certainly do it by taking out one or two ports, or just creating traffic jams, or a train derailment. Anytime that there has to be an investigation, again, go back to Ohio, we had a train derailment last year that had some toxics out there, and they're still cleaning up the mess. Recently, Baltimore Bridge gets hit. That's massive. And again, those are single events. But if you could actually engineer those, the cascading failures really have a impact, accelerator. So that one, research, kind of interesting, maybe a little bit too esoteric. This is one that I actually would even advise you if you have cyber friends or you're in that business. Go ask some of your stakeholders, how would our organization fare if we had something like this? Simultaneous denial of service attacks. So you guys know what a denial of service attack is? Sometimes it's used to extort companies. Sometimes it's used between gaming groups to take out their rival gamers so they get access to servers and they can win all the prizes. In fact, the first legitimate, sustained denial of service attack I saw was by Lizard Squad, and it was against another group that was, and these also, this is all for hire. So everything you're seeing here, these individual TTPs from the bad guys, you can buy those as services on the dark web, or you can get kits. So there's no shortage of actual ways to do it. The issue is the way the world is constructed right now, with data centers, content distribution networks on top of those, telecom. I worked for a telecom company for 15 years. We saw a lot of very interesting things. They all work together. It's amazing anything works, but they also only focus on the things that they care about or they have an SLA responsibility for. And so what we found is that these things are very complicated systems that just work. But when they stop working, that's where it gets interesting. So organizations will spend a lot of money to protect themselves against a sustained denial of service attack. They'll go to their phone company or they'll go to Cloudflare or somebody out there and say, give us, I don't know, I need 500 meg protection. And they scrub it, they switch it around, and they get it scrubbed and it's clean bits. But you ask them, well, what happens if you had 2 of those attacks happening at the same time? Well, then we need, I guess, double that. Okay, we'll go try to buy double that because there is only so much scrubbing capacity in the world. And there's only so many scrubbing centers. Scrubbing center. And they might, I'm not saying, but they might be oversubscribed, meaning you may not be able to get that service that you pay for if everybody's getting attacked at the same time. Then you add something like, well, that's a volumetric attack. It's a very specific attack. We're pretty good at defending it, assuming that you have the capacity. But what if they hit us on the back end or start doing DNS redirects? And so these are all the different types of attack methods that can be used. And most organizations only look at dealing with them one at a time. And what I'm suggesting to you, the new game, simultaneous. And I just buy it. And it's super asymmetric because it's very cheap to get this kind of capacity, and it's very expensive to protect it, even if you were so inclined to do that, and most people aren't. What I would ask is, if you talk to somebody about this, say, hey, do we have denial of service protection in our environment? Oh yeah, we got that, we have that. Well, how much capacity, and what would happen if you had 2 events, and what if they did a little thing here where they were attacking us in 3 different places at the same time? Then I think that's what gets them, oh, we never thought about that. And that's where even just doing a tabletop exercises, some of these things where people can be in the same room and not go, oh, yeah, we should be able to take care of it. Now, the good news is, again, if you're addressing some of these core fundamental issues at that layer 1, layer 3, they translate into protections and goodness throughout the rest of your program. Now, for your organization, whatever your mission is, this may not be the place to spend your limited resources, but maybe it is. And that's why it's important to have the right story, to have the right conversation, to make sure that the threat catalog items that you're concerned with get in there. Okay, this is the last one as far as the use cases go. This is probably one, my research partner, Matthias, he was, what's your obsession with the tsunami warning system? And I said, my obsession with the tsunami warning system is because it all comes together here. You've got these underwater sensors that are getting that seismic stuff, right? Well, they can't transmit any information to anybody else because they're underwater. So they have these buoys, right? And they communicate acoustically there, and then the buoys talk to the satellites, and then the satellites talk to the ground stations, and then what we don't have here is the ground stations then send out Amber Alerts and all that fun stuff. So, anybody who want to mess with this system, this is an interesting target, isn't it? Because a big attack surface, lots of physical things. By the way, when they drop these down there, this is the ocean. I mean, it's maybe off, it may be off the coast, but nobody's actually coming around and servicing these. The location of all these are known, so all of the modeling and stuff that we do uses open source data feeds. And so, yeah, and I think these are also subject to kinetic attacks, right? All of them are. So a multi-domain attack where maybe you take out, or maybe you don't take them out. Maybe you just inject bad data. I call that lying to robots. Maybe you inject bad data in one of those systems, and you can cause a mass flash mob by telling people to go to the high ground because there's a tsunami coming. And I mean, it's not like in the last couple of years we haven't had bogus Amber Alerts, right? Again, attributed to human glitches. Glitches get stitches, in my opinion. And these gremlins that are in the system, it doesn't matter if it's nefarious or it's a gremlin, you can mob these and you can defend yourself against them, but only if you're accepting. And the other reason this is, so, I'm talking about satellite getting hit, underwater cables. And so when I started doing this research, it's amazing. There is an actual conference devoted just to supporting underwater cables. They have submarines you can get, they have sensing information. And when I started looking into this, underwater cables, fiber gets cut all the time. Now, mainly because some cruise ship drops anchor in a place that they're not supposed to, but other times very interesting timings. And Shawana mentioned there's no coincidence or something like that. What happens when that cable gets cut? What happens when that satellite? Well, the very resilient internet networks, when it reconverges. So the question is, how does it reconverge? Does now all your traffic, even though it's encrypted, route through a network that you don't trust, or a country that you're at war with? And Five Eyes, I mean, everything's recorded forever. And disk is cheap, and the reason they record everything forever is because eventually the crypto will fail. And some secrets should have a shelf life, but some of them don't, right? So, if you're 10 or 5 years, if I can get into that half-life there, then I'll have some very valuable information. So we just collect everything. So New Zealand, I was in New Zealand for a wedding, and I love the country we did there. But it's an interesting use case because right now that is my next hardcore model, which is we're going to look at how to isolate New Zealand. Now, part of that is maybe I'm hoping to get picked up at a conference in New Zealand, or it's smaller, right? If we try to model this for another geography, it would be very difficult. But they would fairly easily be isolated, I think, because they only have so many underwater cables coming in. They only are so many satellite flight paths. They have a lot of new infrastructure, but they're not what you would call, well, there's 3 million people, and I know there's more sheep than people there. So they probably don't have that, resources, human resources to kind of go do some of this stuff. And so all of these simulations that we've done so far, manually intensive, take a lot of time, handcrafted goodness. But what we were getting to when we first started looking at maybe how to isolate New Zealand, and again, to engineer and understand failures so that we could present the use cases and the compensating controls to protect those environments. We started building, we had anybody know graph databases, familiar with graph databases? All right. So I had to use them a lot. I love them for visualization, but when we started to build some of these models, we're like, okay, let's just find all the ASNs, let's find who the major telcos are, and put those together. We ended up with a 30,000 node database with millions of edges, and you couldn't visualize it, because the real idea here is to have analysts look at these, test some of these use cases to see, is there even a possible attack path? And now that we're using the 10 domains and some primitives, the maths get very tricky, and I guess it's a computer science problem. We've solved some of that, but this is kind of what satellite ships and submarines, the internet of invisible things. Somebody else's problem. So we've got, and this is a video, I didn't want to try to do a live demo here because of the network maybe, but what we've done is we've taken that 30,000 node database, which was completely unusable and not fit for purpose because we couldn't take it to an executive and say, look, we start out here, but we can get here. So this is our next attempt. We're doing sharding. We're taking just the things that matter and putting them in separate containers and then having the interface be able to access all of those. But what you're looking at is essentially the blue are the ASNs and the peering groups. So do you know what ASNs are? So for the routing, this is how the internet converges at scale. And it's interesting how these get updated because there are a lot of problems with that. It's not secure at all, and it's very antiquated technology, and a lot of it depends on humans talking to each other, right? And those are the humans that are retiring. But you can, and this is the content distribution network, Cloudflare. So these assets that we're looking to affect all live in an Amazon data center, which is abstracted because it's really, depending on which country you come into, you're going to get a different network, and they route you inside. So it's invisible. So we can only know what happens, how you enter it, and how Amazon, because of layer 3 routing, has to respond. This is their Cloudflare overlay. So there's 2 places where we can inject fault, or 2 places that can fail. And our idea here is, okay, let's take out one Kia ASN in the peering group, or maybe not take it out. How do you take it out? You know, kinetically, you denial service it, but maybe I don't want to take it out. Maybe if I find that it's vulnerable, I only want to inject metrics. So everybody understands least cost routing to get the performance. So if the best path and the path that you assume that it's taking, the path that it takes, that communication, trusted communication path, takes all the time, and you're happy with it, all of a sudden it becomes 3 times more expensive from a routing metric standpoint. What happens? Well, it might start routing, instead of through Japan, it might start routing through India, or any of those telcos that were listed in there. So in closing, and I'll turn it back over to Shawana, we can have some Q&A here. This is our first attempt here of only using open source intelligence, and we have to get another dimension here because what we really need to be able to see, this is all kind of layer 3 stuff, we need to be able to see those other 10 layers. So I'm especially interested in going find out who solved some of these problems already, and if I have to buy some special hardware or memory or things like that. But we want to make these models usable by analysts, and we want to make sure that we're focusing on the right use cases because the stakes are pretty high. We have gotten cyber, physical, engineering and computer science coming together, and we're evolving, and hopefully we get the opportunity to evolve more and provide more value to mankind, humankind, or if we don't, well, there are consequences. So with that, I will turn it back over to Shawana for closing. Okay.
So, but there is good news because there are a lot of advanced architectures being prepared. So most of the time we don't end with this, but because it's GEOINT, we knew people would understand it. The Space Force and the space architectures that are being put together, Tranche 1 is how we refer to it. It's a national defense space architecture. There is an enormous amount of the military and the intel community working on this, but there is equally a larger amount of commercial dual-use technologies engaging as well. And that's good news, because for those of us that have been with the IC for a long time, we know how cloistered and secluded we were for a long time, and we tried to keep out of the open source world. And now those worlds are converging. There's also a very, very specifically focused SATCOM architecture for low Earth orbit, mid Earth orbit, and geosynchronous Earth orbit. And those scenarios are being looked at and reviewed, and we're doing these case study modeling and test scenarios, and they're being done constantly. Another very encouraging sign for me is just the bringing in the commercial dual-use technology world to solve problems and look at them while they're still kept isolated and insulated from more of our mission-critical systems. So most recently, for those of you that might have known about it in its early days, it was called Economic Indicator Monitoring, NGA program that was focused on really solving critical infrastructure problems that had big economic indicator risks associated with it. And those risks typically cause civil unrest or some global food security problems, water resource problems. That program was so well received, and in addition, we can't leave out the fact that our government exerts pressure through Congress to use more and more commercial capabilities. But the next phase of that program now has gone from a very slightly funded $30 million program to now a program that has almost $200 million in funding for use case scenarios. It's called LUNO-A, and it's nothing but commercial companies coming together, and the intelligence community will not ask for a product. I don't want this specific product with this specific satellite or airborne imaging solution. They're going to come to the commercial world with a scenario. Imagine, so what if happens if a cable is cut in Djibouti and communications goes down, and at the exact same time, certain roadways are cut off to even get to the port. Tell us what type of data can be used to monitor this situation, what types of outcomes can we look at. And this is a new contract that the request for proposal is out. People have responded, are responding right now. All commercial capabilities, and multiple partners will be given these scenarios and be able to provide their solution. So I think there is a lot of real work being done here. I was asked to write a book chapter, a part of a 10-chapter book 2 years ago. It was space domain awareness, and how could we use everything we've learned in the commercial world and actually utilize that in our critical infrastructure in space, because it is so crowded. My group focused on